Okay, welcome to your pre-calculus final exam review, page 2. State all the functions that are even. All right, so the rules that they want us to know here is that a function is even if f of negative x is equal to f of x. Y equals x squared is a great example. I'd rather us consider it as f of x, okay? And then if we put a negative in there, okay, we're actually going to square a negative number, which means I get back to the original. So if you put a negative into your function and you get back to the original, you know your function is even. Okay, so y equals x squared passes, okay? We'll just do the next easy one, which is y is equal to absolute value of x. Again, I like f of x better. And let's see if he passes the test. So I'll put a negative value in there. That's the absolute value of negative x, which you know is a positive number x. Okay. If you don't see it, just realize that negative x is equal to negative 1 times x, and the absolute value of that is just x. Okay, now the only real problem here now is, they want you to choose either A or B. So far we're looking pretty good over here. So the only one we have to deal with is really cosine. We know this guy's okay, but we got to, if any of these are not okay, that means that's not the answer, right? So if cosine should probably be even, then we'll circle A. If cosine isn't even, then we'll investigate y is equal to sine of x. There's some properties you can just remember, all right? And I'll just tell you right now that sine of x is odd, okay, and cosine of x is even. So if sine of x is odd, that means, what are the rules for odd now? So the rules of odd is that if you have a function f of x that we know is odd, let's say x cubed, okay, we know that that's odd because f of negative x is equal to negative x cubed, which is equal to negative x cubed. So in other words, a function is odd when you put a negative into your function, you get a negative version of your function. I know it looks strange, but you'll see that that's true. So I put negative x, so here's my function. I put a negative in, and I got a negative version of that function. That's the idea there. Okay, so sine is kind of easy to see if you just think of a number that you know well from the unit circle. So sine of pi over 4, let's see, what's that? That's root 2 over 2. But what is sine of negative pi over 4? You can see that's negative root 2 over 2 using the unit circle. That's a nice way to see this, okay, just to see. It's not a proof by any means. And then on the other side of the park, we know that cosine is even. So again, even if we have f of x is equal to f of negative x. That's the idea. And just, again, think x squared, and just, rewind the video and listen to my lecture up there on that topic there. So here, think of cosine of pi over 4, and in the unit circle, that's a positive root 2 over 2. And cosine of negative pi over 4 is equal to root 2 over 2. So even if I put a negative into this function, I still get the same value. So that's another way to understand why we say cosine is even and sine is odd. So now that we know that sine is odd and they want even functions, this becomes really easy. So this one is odd. So the only even functions are these three, all these guys here. So the best choice is A in this situation here with this question. Okay, that was long-winded. Let's see if we can get the next one done sooner. So two functions that have n behavior. I don't know. just challenge this guy here. So I don't know, what would I do? So as x goes to negative infinity, f of x goes to positive infinity. Okay, so I need something like as x goes to negative infinity, f of x goes to positive infinity. So I mean, I just like this guy here. I mean, you can really come up with anything you want. I know that as f of x is equal to e to the negative x. You guys might have thought that was fancy. So I mean, could I use this function here that we all know? So f of x is equal to x squared is another one. And just to keep going, I mean, you can really come up with any function that you want. Now be careful with this one. Realize that this one is the negative version of the cube there. Any of those would do just fine there for number 9. Another good one is the absolute value of x. You know that guy looks like this, and you can see we're getting the same behavior there. So in class, I said this a little bit differently. I said as x goes to negative infinity, f of x goes to positive infinity. So that's what they mean by the limit, and we're going to discuss that more next year in calculus. Okay, so find the limit. So yeah, just graph this guy, and you'll see it's the same thing. They're just asking as x goes to negative infinity, they're asking you f of x goes to what? And we discussed this. Okay, so we know that this is a negative cubic. Okay, so our parent functions, we know we have y is equal to x. Well, I'm doing this fast, by the way. Y is equal to x squared, and this is your cube. So I want to know this guy is the negative version of him. So whatever he's doing, he's he's probably coming down like this and coming up like that. Now I really don't know the middle behavior, I guess. I mean, I know a few things, but I don't know exactly what he's doing. But I know his end behavior. Okay, so the end behavior of this guy says that as x goes to negative infinity, f of x goes to positive infinity, and that's the idea there. Okay, great. Okay, and what's next? Oh, and I think it's asking for both, actually. Sorry. So x is going to infinity and x is going to negative infinity. So as x goes to infinity, we can see f of x is going to, negative infinity. Okay, are we almost there? How many more? Let's see. Just three more. Hang in there. We are at the 8-minute mark. Let's see how we do. This graph the function, describe its position relative to the graph indicated in the basic or the family of functions. I'll say 2 to the x. Okay, you know, if you make x is equal to 0, you know, if you're not sure about these things, always just graph them if you're not sure. So always start with 0. If x is 0, anything 0 power is 1. X to the 1 is 2. X to the 2 is 4, and that's enough for me. So at 0, we get 1. All right, so we're going to get something like this. Okay, so when I see a function like f of x is equal to 2 to the, oops, let me do that again, 2 to the x minus 2 minus 2. I'm hoping my students see that this guy appears in bizarro land. So this is just a shift what? Not left, but right 2 units. And then this minus 2 is outside, so that's a shift down 2 units. All right, straightforward, no problem there. All right, we got a good one. All right, so 5, I don't know why my pen is doing that. 5 to the 8 minus 2x. Play around with it. You'll see that it's 5 to the 4th. Okay, 25 times 25 is 625. And then if you can name the property, you're my hero. 1-to-1 property says that if the bases match, you can just set the powers equal to each other. So negative 2x is equal to negative 4, or x is equal to 2. I would check for extraneous solutions, but this guy looks just fine. If you check your solution, 8 minus 4 is 4, and 5 to the 4th is 625. And the last one, not under 10 minutes, but close. Let's see. This is the one where we have to e it. All right, so we used to get x by itself. Now we're going to get ln by itself. So ln of x minus 9 is equal to 1/8. Oh, a little tricky here. Let's see. So that's going to be e to the ln of x minus 9. Exponentiate, or e it, as we say in France. The x minus 9 pops down. E to the 1/8, I'd just leave it like that. So that's x is equal to e to the 1/8 plus 9 as your answer there. And that's it. So page 2 of your review is officially done.